Question number 2. Let x and y be the real numbers such that 50 times 2x by 1 plus 3i minus y by 1 minus 2y is equal to 31 plus 17i, where I is square root of minus 1. It's an imaginary number. So we need to find the value of 10 times x minus 3y. That's our main goal. So for that, we need to find the value of x and we need to find the value of y. At the first look, this is a complex number problem. It is still we need to compare the imaginary part and real part. So see the right side, 31 plus 17i is already in the form of a plus bi. But in the left side, it's not. We need to convert the left side into a plus bi form, a clean a plus bi form. So we need to rationalize the denominator and do some simplification. We need to convert that first to the a plus bi form. Okay, let's start step 1. Step 1 is understand the question. We have given a complex number. It has left hand side and right hand side also. So both sides are equal. But right hand side is already in the form of a plus ib form. But left hand side is not. So we need to make it exactly in the form of a plus ib form. For doing that, we need to rationalize the denominator first because the denominator has I term there. So the imaginary part in the denominator makes the question complicated. So we need to remove the imaginary part from the denominator. Before that, we need to understand what is a complex number. See, I will quickly explain. A complex number has two parts, a real part and imaginary part. So if we can say two complex numbers are equal, that means the real part of the left hand side must be equal to the real part of the right hand side. Also, the imaginary part of the left hand side must be equal to the imaginary part of the right hand side. This is the key idea we need to use in this problem to compare the both sides and find the value of x and y. So next step is rationalizing fraction. Step number 2. Here we have two fractions in our original equation. 2x divided by 1 plus 3i and y divided by 1 minus 2i. These are the two fractions. So here what we are going to do is we are eliminating the I term, that means the imaginary term from the denominator. So for doing that, we need conjugate multiplication. Conjugate multiplication is something like we are taking the conjugate of the denominator. That means if 1 plus 3i is the denominator complex number, then the conjugate will be 1 minus 3i. That is called conjugate. So we are multiplying this conjugate both numerator and denominator. Okay, let's see. 2x divided by 1 plus 3i. So we multiplying both sides using conjugate. So numerator will be 1 minus 3i and denominator also 1 minus 3i. Here 1 plus 3i times 1 minus 3i. So we use the standard formula of a plus b times a minus b is equal to a square minus b square. So we use this formula and substitute here. Then we have equation like denominator will be 1 square minus 3i square. Now carefully, 3i square. The 3 square will be 9. Then what about I square? What's the value of I? The value of I is square root of minus 1. So I square is equal to square root of minus 1, the whole square. Then it will be minus 1. So we substitute the minus 1 value here. Then what we get? 1 minus 9 times minus 1. It will be 1 plus 9. So 10. The denominator will be 10. So here there is no I term. We completely perfectly rationalize the denominator. After cancelling this numerator and denominator, then we get an equation, and opening the bracket, we got equation like x minus 3ix divided by 5. Now the denominator is completely free from the imaginary number. There is no I in the denominator. Now we can also write this in the form of exactly a plus bi form. See, x divided by 5 minus 3x by 5i. Now this is exactly the form of a plus bi. Okay, now we move to the second fraction term, that one. So y divided by 1 minus 2i. What will be the conjugate of this? 1 plus 2i. So we multiply this conjugate in the both numerator and denominator. So y by 1 minus 2i times 1 plus 2i divided by 1 plus 2i. So we use the same standard form equation here, a plus b into a minus b square, a square minus b square. So we use the same, apply same formula here. We use 1 square minus 2i square. So it will be 1 minus 4 times minus 1. The I square value is minus 1. So we got y times 1 plus 2i divided by 1 plus 4, that is 5. So finally we get y plus 2iy divided by 5. So this equation we can write in the form of a plus bi form. So y divided by 5 plus 2y divided by 5i. So the both fractions here are free from imaginary numbers in the denominator, and now exactly the form of a plus bi form. Now step number 3, substitute rationalized form into the original equation. So we use this rationalized to a form of the fraction back to our original equation. So we got 50 times x by 5 minus 3x by 5i minus 5 by y by 5 plus 2y by 5i is equal to 31 plus 79. So do we have the same denominator, all 5? So we can write it numerator together. So 50 times x minus 3xi minus y plus 2yi all divided by 5 is equal to 31 plus 17i. So now we have our equation rationalized form. So there is no imaginary terms in the denominator. So denominator is exactly 5. It's simplified form. Next step 4, simplify. So now we are going to simplify the left hand side as much as possible to make the left hand side in the form of a plus bi. First we take this 5 out and cancel with the 50, and 10 will be there left. And then we are opening this bracket by distributing this minus sign to each term. So x minus 3xi minus y minus 2yi. Now what we're going to do is we are rearranging. So the real part on the left side and the imaginary part on the right side. So real part will be together and imaginary part will be together there. And now we are, next step, we are introducing a bracket here. Why? Because we are introducing bracket here, so we minus sign will be plus. So inside minus 3xi minus 2y. If you open the bracket, this same term will be we get the same term. Next is we take the I from the each term outside. So 10 times x minus y plus 10 times minus 3x minus 2x I. So we take the I out from the imaginary term. Now we multiply the 10 with the each term. So 10x minus y. Let the left hand side stay same. The right hand side we distribute this term to 10 to inside the bracket. So minus 30x minus 20y. I is outside here. So now see, the left hand side exactly look like a plus bi form. So this is a, the real part. This is I, this is imaginary part. So 10x minus y plus minus 30x minus 20y I is equal to 31 plus 79. So left hand side also a plus bi form, right hand side also a plus bi form. Now things are very easy. Step number 5, compare the real and imaginary parts. So we already know that the left hand side right now in the form of a plus bi form. So the real part of the left hand side is equal to the real part of the right hand side. We already know that if two complex numbers are equal, that means the real part of the left hand side must be equal to the real part of the right hand side. Same as the imaginary part. If the imaginary part of the left hand side must be equal to the imaginary part of the right hand side. So that idea we are going to use in the next step. So we have the real part here. Compare the real part. So 10x minus y is equal to 31. We got the real part. Then the imaginary part, see, minus 30x minus 20y is equal to 17. So we have the two equations, a system of equations. 10x minus y is equal to 31 and minus 30x minus 20y is equal to 17. Now we already know how to solve this system of equation to find the value of x and y. In next step, we are going to do that. Now step 6, solve the system of equations. So we have two equations here, a system of equations. Take the first equation, 10x minus y is equal to 31. So 10x minus y is 31. And find the value of x. So x minus y is equal to 31 divided by 10. Then x is equal to 31 divided by 10 plus y. That is, we can write x is equal to y plus 31 divided by 10. So we need to find the value of y also. Then only we get the value of x. So keep this equation as it is. Now we take the second equation. Minus 30x minus 20y is equal to 70. In that equation, we substitute this value x into that equation. So minus 30, the x value x equation is y plus 31 divided by 10 is minus 20y is equal to 70. And distribute the 30 in the bracket. So 30 minus 30y minus 30 times 31 divided by 10. So this 30 and 10 is cancelled and it will be 3. Minus 20y is 70. So again, next minus 30y minus 3 times 31 is 93. So minus 30y minus 93 minus 20y is equal to 70. So the y terms add together. So minus 50y we get minus 30y minus 20y is equal to minus 50y minus 93 is 17. So move the 93 right hand side. So minus 50y is equal to 17 plus 93. So y is equal to 110 divided by minus 50. So y value will be 11 minus 11 divided by 5. So now we got the value of y. So we substitute the value of y into this x equation to find the value of x. After finding the value of y, substitute this y value into the x equation. So we can find the x value. So x is equal to minus 11 by 5 plus 31 divided by 10. So LCM is 10 to make the denominator 10. So 2 times minus 11 plus 31 divided by 10. So x is equal to minus 22 plus 31 divided by 10 is equal to 9 by 10. So x is equal to 9 by 10. Now we have x value and y value. And what we going to find? We need to find 10 times x minus 3y. Now it's very easy to find this equation. Now step number 7. Compute 10 times x minus 3y. So we have the value of x and we have the value of y. So substitute the x and y values in the equation. So substituting 10 times x value 9 by 10 minus 3 times y value minus 11 by 5. So after multiplication, we have the LCM. We take the LCM 10 for make denominator same, and 9 plus 33 divided by 5. So 3 times 11 is 33. Okay. So then 9 divided by 10 plus 2 times 33. That means to make the denominator 10. So 9 plus 66 divided by 10 is equal to 10 times 75 divided by 10. So 10 and 10 cancel. So 10 times x minus 3y is equal to 75. Option number 4.